What we just did in our last exercise with cul-de-sacs is how we really deal with intersections as well. We're dealing with curb returns and any of those locations, we're going to create an alignment or profile feature line, something like that, that linear path, and then target back to our alignments. Now that's a lot of work. It wouldn't be great if it was automated. Let's look at how Civil 3D has automated the process that we just did in the cul-de-sac design exercise for intersections. So it's not automated for cul-de-sacs and not perfect for every type of intersection, but 3-way and 4-way type intersections, we can use an intersection object. And that's what we're going to do. In the home ribbon, create design panel, you have a few different controls under the intersection, including roundabouts. It's a really powerful horizontal control designed for roundabouts. We're going to focus here on create intersections. To create an intersection, it says select the intersection point, and we're going to select where those two alignments come together. It's going to go ahead and place a Civil 3D intersection style there. We're not going to place a label, put it on the right layer. All of these, of course, coming from our settings. There's two different ways to create an intersection object. What we're ultimately doing is we're linking the horizontal and vertical of these two alignments and profiles that come together at this intersection. Now, if you link the primary with the secondary, how do you want to deal with the secondary? Do you want all the road's crowns maintained, which may mean the roads flatten out a bit where they intersect, but it also means it would only place one new PVI, a linked PVI, at that location. If you say primary road crown maintained, notice the 3 dots here. They represent how many PVIs are going to be controlled for the secondary profile. Is going to be locked and changed dynamically based upon the primary profile and its elevations. So if you want additional PVIs and making sure you have that 2%, you do primary road crown maintained. We're going to do all crowns maintained in this exercise. I'm going to go ahead and click next, and notice here it provides us the intersecting alignments. And it immediately knows that if there's a layout type profile, it's going to select that as the option. But it does allow you to change the profile that you're going to link between these alignments. Omega Way is going to be the primary. And that's this one coming this direction. Because this is a T intersection, the through alignment must be the primary, whereas the one that intersects at that location must be secondary. Now, if this was a 4-way intersection, and then you'd have these arrows that are currently grayed out, allowing you to choose which alignment is going to control which one's priority, which one's secondary. You know what? Before I continue, though, notice everything else is optional. I can uncheck all of these other options here, and everything else is optional. I use intersections often just to link profiles, so that as I'm designing, I know that the start of one profile and the cross of the other profile, when one profile moves, all of them are linked together through these intersection objects. Of course, we're going to continue. We're going to see all the features here of the intersection object. The offset and curb return features really deal with the horizontal. And so our offset parameters control the lane widths here. And so our primary road left lane is 12 feet wide. Our secondary or our primary road right lane is 12 feet wide. We could change these, or we can even link the alignments or the offsets to alignments. Because the primary road could have different offset distances than the secondary, we have to repeat and confirm these here as well. That provides the horizontal. What about the actual radius and curb return values here? So it provides us this little view, and not only in the parameters window, but we also have some glyphs or previews of which quadrant that we're working in. So in this quadrant, we're going to choose to use a circular fillet instead of a chamfer or a 3-centered arc, and use a radius of 25. Now, if we make any changes here, don't forget we've only changed this quadrant to the corner this direction. make sure you hit the next to set all the values correctly. So that handles the horizontal controls. That really will create a bunch of different offset alignments that are linked. This provides vertical control. So we're going to have the ability to have lane slope parameters. The lane slope parameters means that we need to set the slopes for the left and the right, primary and secondary. What this does is the software simply says, give me the distance, give me the slope, and I will dynamically link profiles to the centerline profile. And when the centerline profile adjusts, these dynamically linked profiles will adjust as well based upon these parameters. Really powerful. So we have those set. And then curb return, same scenario. Of course, it'll take those slopes at that location and just create a profile that is linked for those slopes. So the curb return profile parameters here, they're really more connected to the idea of how we're dealing with that transition. And so right here is our point of curvature, one of the two. And what we're going to be dealing with is you have a slope along this road here. Let's say it's 5% coming down, and you have an 8% road here. And so what you might run into is this curb return is getting into 15%, going from this slope for the road to this slope of the road. And so some jurisdictions set the criteria that to flatten that curb return out more, you're going to extend along the edge of your lane the flattening. In other words, the lane slope may flatten out from 2% to 0, almost kind of like a super elevation scenario, so as to better deal with the curb return. Because most of the jurisdictions that I've ever worked with don't require that, I've changed my command settings to say, no, do not extend along the profile incoming and outgoing. I don't want to change my lane slope. I want my curb return profiles and slopes to be whatever they are. If there's an issue with that slope, if it's too great, I need to go back to my baseline profile design and review it. But you can extend it, and you can choose how long or how far to extend it in those lanes. Now, realize what we've just done is if we've made the change, we've only made it to this quadrant. We're going to change that quadrant. That means incoming, outgoing, and the distance in both directions. So that sets all of the controls. We mentioned for corridor you need linear path. Here's your linear path. You also need assemblies. On the next wizard, we're going to add this to an existing corridor, our Osceola Road corridor. Any assemblies or sub-assemblies that have daylight controls, we're going to daylight to EG. And then we literally have to walk through each assembly to add. Now we've added these assemblies already to the drawing. The nice thing is though, it gives a nice good look at where it potentially will use those assemblies and what assembly may look like. That visual gives us a good control. So that one we've seen before. That's lane left, curb right. That one we've built. That was the main road. And some of these I built for you already. And so we'll just walk through setting these together. Now this takes a lot of time to set all of these ones for the primary, and then we have to go through the secondary. Wouldn't it be nice if it just remembered these settings and we just picked the right saved set? Well, that's available right above where we set all these different values. You can create an assembly set, save all these different values, and then simply browse to that saved set so you don't have to do this again. So I encourage a lot of companies, especially when they work in jurisdictions a lot, if you work in the same county or city, you set all and create your assemblies for that, and then save them as a set, and you're ready to go. Well, we've done all the work. Let's go ahead and create an intersection. And we see the intersection object created for us. Now, again, this is not a separate corridor. It's all part of one. So what we really need to do is pull all of this back together. I created separate regions along this road and shrunk the regions for this one. And just so I had enough space to put that intersection object in, and now I have to pull it all together. Now I could use the diamond grips. We know what they are by now. We can slide the region end station or start station along the path of the baseline. What I found though graphically is it's just not very easy to use those grips. So we're going to go to the corridor properties and we're going to find the region in this very big list. That's too hard. What if we graphically could find the right region? So I'm going to select the region from the drawing and I'm going to go ahead and pick this region. Now notice the alignment stationing, 7 plus 0, 0, and 7 plus 60. When I select this region, and notice the blue graphic that shows this region's end and edge, and it shows it gray in the corridor properties. So what we're changing is the end station of that region. Now, instead of typing something in, I'm going to pick graphically, using my object snaps, the end of this assembly, or this edge here for this region. So it'll pull it all together. And we're going to repeat the process for the through road as well. So again, look at the stationing. You have 5 plus 0, 0, and 4 plus 0, 0. So what we're doing is we're extending the end station of this region. Select it. Pick the end station. Graphically pick it. And I know I'm going to be changing the start station of the next one. You notice how much difference in station there is, horizontal distance. I hit the start station here and pan over. And I'm changing this region here and changing its start station to line up there. I have all the settings, so I hit OK. It's going to rebuild the corridor, and notice it pulls it all together, and so it acts as one corridor object. Contours and everything come together cleanly as it wraps around the curb return. And the nice thing is this whole section here is dynamic. I change the profiles or any settings here that impact this intersection, all of the intersection objects and the connections of all those intersection objects will come together. Very powerful means to automate what we really did manually in the last exercise.